Hi, welcome to SR Concepts, and in this video we are continuing the chapter Is Matter Around Us Pure from NCERT textbook of Science for class 9th. And the topic that we are going to start with is what is a solution. So, dear students, mixtures can be divided into three different categories depending on the particle size. And this is the solution, suspension and colloid. So first of all, we are going to start with what is a solution. So solution is a homogeneous mixture of two or more substances. We know what is a homogeneous mixture. Homogeneous mixture has a uniform composition and has same properties throughout, and in which the components are dissolved completely in each other. So any type of homogeneous mixture can be called a solution. So generally we think that solutions are liquid, but actually the solutions can be maybe solid solutions also, like alloys, which is a mixture of metals and non-metals or metals plus metals, and gaseous solutions also. For example, air is a gaseous solution because air is a homogeneous mixture of different gases. Now there are liquid solutions also. For example, ink may be a liquid solution, or if we dissolve salt in water, then it is a liquid solution. Okay, so what is a very particular, very special character of solution is that there is a homogeneity at particle level. Means if we talk about lemonade, which is a homogeneous mixture, which is a solution, right? Then homogeneity at particle level means that particles of sugar and salt are evenly distributed throughout the solution of the lemonade. Okay, so now there are two important components of a solution. One is solvent and the other is solute. The solvent is that component which dissolves the other component, and which generally is in larger amount. So if we talk about a solution of water plus salt, so water dissolves the salt, so water will be a solvent, and the solute will be salt, because solute is that component which is dissolved in the solvent. The solute is that component which is dissolved in the solvent. So salt is solute and water is solvent. Now, properties of a solution. These are the important properties. We know that solution is homogeneous mixture and particle size is smaller than 1 nanometer. This is 10 to the power 9 meters. This is 10 to the power 9 meters, right? 10 to the power minus 9 meters. Okay, so they cannot be seen with the naked eyes, and because the particle size is very small, so when you will pass a beam of light through them, they do not scatter the beam of light, and this scattering of light is called the Tyndall effect. And so we can say that in a solution, Tyndall effect is not seen when the beam of light is passed through the solution, right? The scattering of light doesn't take place because the particles are very small. Now the particles are very small, so that's why they cannot be separated by the process of filtration, right? So, and when you leave solution for undisturbed for some time, then you will see that the particles will not settle. That means the solution is stable in nature. Now, concentration of a solution. So this is a way of describing the composition of a solution. So by the help of expressing the concentration of a solution, you can express the composition of the solution. Composition means in a solution how much amount of which component is dissolved. This is expressed and this is called composition. So what is concentration? This is the amount of solute, present in a given amount, mass or volume of the solution is called concentration of the solution. Okay, so here we come. There are three different methods of expressing concentration. One is mass by mass percentage. This is mass by mass percentage, right? This is also sometimes referred weight by weight percentage, right? So for calculating this, we can put the mass of solute upon mass of solution into 100, right? Into 100. In the same way, mass by volume percentage, right? And then we will put the value of mass of solute and volume of solution this time, and we will multiply with 100. In the same way, volume by volume percentage, volume of solute upon volume of solution into 100. So the concept of concentration can be discussed, can be understood well by the help of this example. So in this example, suppose we take 40 gram salt, table salt or common salt, and 320 gram water. We dissolve 40 gram salt in 320 gram of water. Now we have to find out its concentration in mass by mass percentage. Okay, so here you see the amount of salt was 40 gram, the amount of water was 320 gram, that was the solvent. So here you know that the solute is salt and the solvent is water. So the total mass of solution will become 40 gram, that is the mass of solute, plus 320 gram, that is the mass of solvent. So the total mass of the solution will be 360 gram. Now what is concentration? Once again recall that concentration is the amount of solute dissolved in total amount of solution. Okay, so mass by mass percentage, if we express the concentration in mass percentage of the solution, then we will put mass of solute upon mass of solution into 100. Mass of solute is 40 gram, mass of solution is 360 gram into 100, then the concentration will become 11.1. So this expression 11.1%. This is the expression of concentration of the solution in mass percentage or mass by mass percentage of the solution. So this expresses the composition. How this expresses that 11.1% mass is of NaCl, that is salt, and the remaining 88.9% is water. So in 100 gram mass of the solution, 11.1 gram mass will be salt and 88.9 gram mass will be of water. So this is how concentration expresses composition of the solution. Now some important definitions: saturated solution, unsaturated solution, dilute solution, and concentrated solution. Saturated solution means that solution which has maximum amount of solute, right? The maximum amount of solute dissolved in it at a particular temperature. For example, at we take 100 gram of water, 100 gram of water, right? And we start dissolving salt in it, and the temperature is suppose 293 Kelvin. So at 293, 100 gram of water, in 100 gram of water, maximum 36 gram salt can be dissolved. At 293 Kelvin, in 100 gram of water, maximum 36 gram amount of salt can be dissolved. So if a solution contains 36 gram salt dissolved in 100 gram water at 283 Kelvin, then this will be called saturated solution. Okay, but if we increase the temperature, then this amount can be increased, that the total soluble amount can be increased, then the saturated solution will be having different amount of salt dissolved in it. So a solution which has maximum amount of solute dissolved in it at a particular temperature is called saturated solution. If you add 36 gram in 100 gram water, 36 gram salt in 100 gram of water at 293 Kelvin, then this will be called a saturated solution. If you dissolve 2 more gram, then this will not be dissolved. If you add 2 more gram salt after dissolving 36 gram, then this 2 more gram extra salt will not be dissolved in water. Okay, now unsaturated solution is that one which has less and which has the amount of solute dissolved in solvent lesser than its solubility. Means we know if we take 100 gram water and we dissolve only 30 gram NaCl salt in 100 gram water at the same temperature 293, then the maximum amount can be dissolved is 36, but actually here how much amount is dissolved? 30 gram is dissolved. So this will be called an unsaturated solution, having lesser amount than its capacity. Okay. Now dilute solution is the solution having relatively less amount of solute, and concentrated solution having relatively larger amount of solute. For example, we make a solution in 100 gram water. 100 gram water and we dissolve only 5 gram or 2 gram NaCl. If we add 2 gram salt or NaCl, then this solution will be called dilute solution. And if we dissolve 30 gram, if we dissolve 30 gram salt, then this will be called concentrated solution. So these terms are relative or qualitative terms, dilute and concentrated. Okay. Now what is solubility? The maximum amount of solute present in a saturated solution at a particular temperature is called solubility. So saturated solution of NaCl, we know that 100 gram of water, in 100 gram of water, 36 gram, that is the maximum amount of salt. 36 gram salt is dissolved in 100 gram at 293 Kelvin. So at 293 Kelvin, solubility of salt in 100 gram water is 36 gram per 100 gram water at 293. So what is solubility? This is the maximum amount of solute that can be dissolved in a given amount of solvent at a particular temperature. This amount, this 36 gram per 100 gram, is called solubility of the salt. So the amount of solute, we can say the amount of solute present in a saturated solution at a temperature, at a particular temperature, is called solubility. Now the effect of temperature on solubility is that when you increase the temperature, the solubility of that solute in that solvent increases, right? And if you decrease the temperature, then the solubility decreases. Means, suppose at 293 Kelvin you have dissolved 36 gram salt in 100 gram water, right? Now if you want to dissolve 5 more grams NaCl, you know that 293 you cannot dissolve more than 36 gram. But if you want to dissolve 5 more gram NaCl, right, or salt in the same amount of water in the same solution, then you will have to heat the solution. If you heat the solution, then possibly you will be able to add a little more amount of salt. That means then the solubility will become 36 plus 5, that is 41 gram at a higher temperature. So when you increase the temperature, more amount of a substance can be dissolved in a solvent. So this is the effect of temperature on solubility, that the solubility increases by increasing the temperature. Okay, now this is an example. However, this is a question from your NCERT exercise. We will not discuss this completely here, but from this table I want to show you the concept of solubility. Suppose there is a girl, right, and she taken 4 different salts. One is potassium nitrate, then is sodium chloride, then potassium chloride and ammonium chloride. Okay, she took 100 gram water in 4 different beakers, right, in 4 different beakers. Suppose in first beaker we dissolved she dissolved potassium nitrate. Okay, she took a beaker, okay, and she took 100 gram water in it. Okay, and initially the temperature is 283 Kelvin. The temperature is 283 Kelvin, and she starts dissolving potassium nitrate. So she found that maximum amount of potassium nitrate was 21 gram. Potassium nitrate could be dissolved in 100 gram water at 283 Kelvin. So we can say that the solubility of potassium nitrate at the temperature 283 Kelvin in water is 21 gram per 100 gram water. Okay, in the same way, now after dissolving 21 gram in 100 gram water at 283 Kelvin, she tried to dissolve more potassium nitrate, but it did not dissolve. Now she increased the temperature from 283 to 293 Kelvin. This time, initially 21 gram was the maximum amount which was dissolved in 100 gram water. But when the temperature was increased to 293, right, she found that a little more amount, that is total 32 gram of potassium nitrate, now could be dissolved in 100 gram water. So how much extra amount of potassium nitrate was dissolved? 32 minus 21, that is 11 gram extra amount could be dissolved, uh, in the same amount of water, that was 100 gram at the temperature 293. So here we see that the solubility, that is maximum amount of solute that can be dissolved, has increased on increasing the temperature from 283 to 293 Kelvin. So the solution of this question we will discuss separately in the video of NCERT solutions. Okay. Now let's move on to the next category of the mixture, that is suspension. So dear students, we know that if we dissolve salt in water, that is a solution. But if we mix sand or chalk powder in water, then this will be an example of suspension. What are the features? What is the definition of a suspension? We can say means what are the features of suspension? That it is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. And the most important feature is that the particles of the suspension are visible by naked eyes. So in a solution you cannot see the particles, but in a suspension you can see the particles. So if you dissolve sand in water, this is water and you dissolve sand, then the particles of sand can be seen individually, right? Individual particles can be seen with the naked eyes. So then this mixture will be called a suspension. Okay, so examples are mixture of sand or mud in water, right? A mixture of chalk powder in water. Now what are the properties of suspension? The properties of suspension, first is that it is a heterogeneous mixture. Second, the particles can be seen with the naked eyes because the particles are very large. And the third thing is that when you pass a beam of light through a suspension, suppose you throw torchlight on the suspension, then the particles are so big enough that they scatter the beam of light passing through it. And because of this, a path of light will be visible in the suspension. So we can say that the Tyndall effect is visible. This is called Tyndall effect. When the light is scattered by the particle, then it is called Tyndall effect. Now if you leave a suspension for some time undisturbed, then you will see that the particles will settle down. Means if you dissolve sand in water and you mix it and then you leave for some time, then you will see that most of the sand has come to the bottom. It has settled. The particles have settled to the bottom. So you can say that the suspension is unstable. Then the particles of a suspension can be separated by the process of filtration because the particle size is very large. Generally the particle size is more than 100 nanometer. So the particles are larger than 100 nanometer. However, in some other texts or some websites you will find this data something different. But generally we take that if the particle size is larger than 100 nanometer, right, then it should be in the category of suspension. Now, so the particles can be separated by filtration. Okay, and if you leave the suspension for some time, then the particles settle down. That means the particles settle down. That means the suspension breaks. So once the particles settle down at the bottom, it is said that the suspension has broken, right? And then it will no more scatter the beam of light, means it will no more show the Tyndall effect. Now what is a colloidal solution? This is the last topic of the video. So in a colloidal solution I will discuss that particles of a colloid are uniformly spread throughout the solution, right? But due to relatively smaller size of particles as compared to that of suspension, the mixture appears to be homogeneous. right? So actually colloid is a heterogeneous mixture, but it seems to be a homogeneous mixture. And here the particle size is intermediate. So in a colloid the particle size is 1 nanometer, 1 nanometer to 100 nanometer. So here you see less than 1 nanometer is solution, 1 to 100 nanometer is colloid, and if the particle size is more than 100 nanometer, then it will be called a suspension. Okay, so the examples of colloid are milk, right? The mixture of egg white and water. We can make it if we if we add a little egg white in a little warm water, then it will be a colloid. Then if we dissolve, if we add a little starch, little amount of starch in warm water, then it will also be a colloidal solution. Soap in water is also a colloidal solution. Now properties of colloid. Colloid is a heterogeneous mixture, right? And the particles are too small because the particle size is 1 to 100 nanometer, so they are too small to be individually seen with the naked eyes, right? And but they are yet big enough, the particles are yet big enough to scatter a beam of light passing through it and make its path visible, and this effect is called Tyndall effect. So we can say that colloids also show Tyndall effect. You know that suspensions in solutions there is no Tyndall effect observed, but in suspension and colloid both the Tyndall effect is seen, that is the light is scattered and the path of light is visible. Okay, so when you leave them undisturbed, the colloids generally do not settle down. Particles do not settle down. That means they are quite stable. So colloids are quite stable. They cannot be separated by the from the mixture by the process of filtration because the particle size is very small. They cannot be filtered out. Okay, but there is a process known as centrifugation which can be used for separating the particles of a colloid from the mixture. Now components of a colloid. As a solution has two components, one is solute and the other is solvent. You know that generally solute is in smaller amount and solvent generally is in larger amount. In the same way, there are phases, dispersed phase and dispersion medium. So dispersed phase is solute like component which is dispersed in colloid in the form of dispersed phase, right? So dispersed phase is just like a solute which is relatively smaller in amount and which is dispersed, the particles of which are dispersed in another substance which is in another component which is larger in amount. Now the another component which is larger in amount generally, right, and the component in which dispersed phase is suspended is known as dispersing medium. Dispersing medium, right? So dispersed phase and dispersing medium. Okay, so examples in a colloid solution of soap in water. If we talk soap in water, right, this is again an example of colloid, right? Then soap particles will be dispersed phase and water is a dispersing medium. Now we will talk about classification of colloids. So the colloids are classified on the basis of the physical state of their dispersing medium and dispersed phase, that may be solid, liquid or gas. So here you see dispersed phase, dispersing medium, type and examples are written. So the colloids are classified into these different types depending on the state of their dispersed phase and dispersing medium. So first is aerosol. This is a aerosol in which dispersed phase is liquid and dispersing medium is gas. So if we talk about cloud or fog, we will see that there are small droplets of water, that is a liquid are dispersed in a large amount of air. So the liquid droplets form the dispersed phase and the air forms the dispersing medium. So here you can see that dispersed phase is liquid and dispersing medium is air. In the same way, so this is a type of aerosol. So there is another type of aerosol in which dispersed phase is solid and dispersing medium is gas. So if we talk about smoke, right, or automobile is exhaust, so you know that in a smoke there are unburnt carbon particles which are solid. So these are dispersed phase and they are dispersed in air. So the air is dispersing medium and this is in gaseous state. So aerosol is of second type. This aerosol is of second type in which dispersed phase is solid and dispersing medium is gas. Okay, now if we talk about foam, then foam is also type of colloid. In this foam, dispersed phase is gas and dispersing medium is liquid. So shaving cream is the example of it. Now emulsion is again very important. Milk and face creams are the examples of emulsion. Here you see that that the dispersed phase is liquid and dispersing medium is also liquid. So emulsion, you can obtain an emulsion by by taking a little amount of water and mixing a little amount of oil in it. Okay, so if you shake it vigorously, then the particles of oil will become very small, right? And they will remain dispersed in the water, and this mixture will be called an emulsion, because the dispersed phase oil is also liquid and dispersing medium water is also liquid. So when dispersed phase and dispersing medium both are liquid, then it makes an emulsion. Okay, now milk of magnesia, and this is called sol. So another category of colloid is sol, and in sol the dispersed phase is solid and dispersing medium is liquid. So the examples previously given to you, like mixture of starch in water, right? Mixture of starch in water may be called a sol, right? So sol is the most common type of colloid, and in this dispersed phase is solid and dispersing medium is liquid. So milk of magnesia is a mixture of water plus some hydroxides of metals like magnesium hydroxide. Okay, and mud is also a colloid. Here you can see. Then there comes foam. There is another category of foam in which gas is dispersed in solid, and the example is rubber, foam, soap, pumice, right? Then sponge and pumice, not soap. Okay, then comes the gel, right? In gel a little amount of liquid is dissolved, not dissolved but dispersed in dispersing medium, and the example of this is cheese, butter and jelly. In the same way solid sol, in solid sol dispersed phase is solid, dispersing medium is solid, is also solid. And colored gemstones and milky glass, these all are the examples of solid sol, milky glass and colored gemstones. Now finally a very important topic, that is Tyndall effect. What is Tyndall effect? Here you can see the Tyndall effect. You see that if you take a solution and you pass the beam of light, then in a solution there will be no path of light visible. Here there is no path of light visible, but here you, in this container, you have taken a colloid or a suspension. So if you take a colloid or a suspension, then after some time, when you will throw the light, when you will pass the beam of light through it, you will see that the path of light is visible. This visibility of path of light is because the particles of colloid or suspension are big in size and they're scattering the beam of light. So here you can see in the morning or evening time, generally you see, even in daytime you see that in dense forest canopy you see that the streaks of light are coming, these beam of light are coming, they are visible. This is because of Tyndall effect, because in air there are many very small particles which are in colloidal state. So when the light passes through the air, right, then these colloidal particles scatter the beam of light, and this is why you are able to see the beam of light passing through them. That same phenomena can be seen when you are inside a room that is closed from all sides and there is a sunny day, but there is a small hole in the wall or in the window, right, and a streak of light is coming through the window, and however whole the room is dark, there is no source of light, but a streak of light, a beam of light, not a streak but beam of light is coming from a hole inside the room, then you will see carefully that some particles are moving in that particular area of air, right? So that is also because of colloidal particles of air. Thank you for watching this video, dear students, and in the next video we will be discussing about the different methods of separation of components of mixtures, different components of mixtures.